Today we're starting the chapter on radicals and roots. So 9.1 is an introduction to those radicals and radical functions. I know I've got this when I can find square roots, cube roots, and nth roots, approximate square roots, simplify radicals containing variables, and graph square and cube root functions. But some key vocabulary, it's the beginning of a chapter, so you're going to have more. It's square root, principal square root, negative square root, radical, radicand, radical expression, index, the nth root, perfect square, irrational number, and approximation. So a radical expression contains a radical sign with a radicand number underneath. So the number underneath the radical is called the radicand. A square root, if the radical is, if a is a positive number, then the square root of a is the positive square root of a, and the negative square root of a is negative square root of a. So the square root has to be positive too. It has to be greater than or equal to 0. To find the square root of a number, we find a number that was squared to get a. So for example, 64, the square root of 64 is 8 because 8 squared is 64. Both 8 and negative 8 are square roots of 64. We denote the non-negative or principal square root, positive square root, with the radical sign. The square root of 64 equals 8. We denote the negative square root with a negative radical sign. So if the negative is in front of the radical, you say it's negative 8. So like you just carry it in front, and that works. But if you have something like this, that would be no solution because you can't have a negative under the radical sign. So example 1a and 1b. So I'm going to do some and then you're going to do some. So what times what gives us 49? 7. What times what gives us 0? 0. So you would say the square root of 49 is 7, the square root of 0 is 0. Now, let's try to do these together. What is the square root of 25 over 16? Well, what's the square root of 25? 5. What's the square root of 16? 4. So it's just 5 over 4. Okay, when you have a decimal, the square root of 36 is 6. So you would say it's 0.6 because 0.6 times 0.6 is 0.36. So you try these, go ahead. And you should have gotten, so this would be 1/6, negative 3, and G is no solution because it has a negative underneath the radical sign. The cube root of A basically is, you ask yourself, what times itself 3 times would give me that number? So for example, okay, the cube root of 27. So what times itself 3 times gives you 27? 3 times 3 times 3. So it's 3. What times itself 3 times gives you negative 64? Now you wouldn't say no solution because this is an odd index number. So it's only no solution when you have an even index number. Okay, because negative 4 times negative 4 times negative 4 would give you negative 64. Okay, now what times itself 3 times gives you 27? We said already 3, and then what times itself 3 times gives you 64? 4, so it would be 3 over 4. All right, so this one, what multiplied by itself 3 times gives you negative 8, negative 2, and then 27 is 3, so negative 2 over 3 would be that answer. So you try this one. So what times itself 3 times gives you negative 216? You should have gotten negative 6. So other roots can be found as well. The nth root of A is defined as the nth root of A equals B. Only if B to the n power equals A. So if the index n is even, the root is not a real number when A is negative. So that's what I said before. If you have the square root of negative 9, that's going to be no solution. But if you have the cube root of negative 27, that would be negative 3. So if the index is odd, the root will be a real number. But if it's an even index, like this is assumed to be a 2, then that would be no solution. Okay, so let's try these. So 256 is something times itself 4 times. So it would be 4, because 4, watch, because 4 times 4 times 4 times 4 equals 256. How do I know this? 4 times 4 is 16. 4 times 4 is 16. 16 squared is 256. So that's how I know that. Okay, what times itself 5 times gives you negative 32? Negative 2. What's the square root of negative 36? Negative 6. Now let's do this one. So, okay, we have a negative in front, right? So I can keep a negative sign because of this. What times itself 4 times is going to give me 81? 9. What times itself 4 times is going to give me 625? 5. So it would just be negative 3/5. You try that one. What is the cube root of 27? 3. Okay, now we have variables. So let's try some of these, okay? What times itself would give you x to the 8th? X to the 4th, because remember, when you multiply, you add your exponents, right? So what times itself would give you x to the 8th? X to the 4th times x to the 4th. So keep that in mind. So what's the square root of 16? We would say 4. And what times itself is going to give us x to the 14th? X to the 7th. What's the cube root of negative 8? Negative 2. What times itself 3 times is going to give us x to the 6th? X squared, because x squared times x squared times x squared, remember you add your exponents, gives you x to the 6th. Okay, so now what multiplied by itself 4 times is going to give you 16. 2. 2 times 2 times 2 times 2 gives you 16. All right, and then this one, so these are for you to do, so go ahead and try. And you should have got negative 3 and negative 3/5. All right, now, when it asks for the approximation of a root, you can use your calculator. Using a calculator gives an approximation, and leaving an answer in radical form is the exact value. You can do all of this on your calculator. Let's practice together. Approximate the square root to 3 decimal places. So if you do not know how to do this on your calculator, you need to let me know so I can show you. So if you put these in your calculator, you should get these as your answers. So just let me know if you don't, because that's all just learning how to use your calculator. Now we're going to be finding function values, which means to substitute the given value in for x to see what the y value would equal at that point. Okay, so if f of x equals the square root of x minus 5, and g of x equals the cube root of x plus 3, find each value. All right, so what this means is this is saying the to find f of 9. So we're going to use the f function, and wherever there's an x, I'm going to plug in that 9. So I would get the square root of 9 minus 5, which is the square root of 4, and that's 2. So then in B, it says find f of 11. So I'm going to plug that 11 in right there. And I would get the square root of 11 minus 5 equals the square root of 6. Now, unless it says approximate the value, you're going to leave the answer in exact form. That means that unless it says exact value, you do not use your calculator, and you have to leave it as a square root unless it's a perfect square. Okay, so you go ahead and try these. And you should have gotten g of negative 2 would equal 1. And g of 3 equals the cube root of 6. Now, so you are going to use the g function in both of these and plug it in for this x. And notice I took the cube root of 1, which is 1, because that's a perfect cube, but there is no cube root of 6. That's an exact value, so I left it as the cube root of 6. So remember, only when it says approximation do you actually just use your calculator. Okay, example 6a. Graph the square root function f of x equals the square root of x. So we're going to identify the domain. So to do that, you're going to set the radicand greater than or equal to 0 and solve. So you take what's under the radical and set it greater than or equal to 0. So evaluate the function for several values of x, plot the resulting points, and connect it with a smooth curve. So we are going to try this. All right, so if I said the domain starts at 0, and so I'm going to plot those points. Now, the reason that I'm plotting these points in for x is because those are all perfect squares, and I want to end up with no decimals if possible. Okay, so if I plug in, remember, y is the square root of x, right? From right here. Okay, so the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So I'm going to show you what all those points look like. So we're going to plot all these points and then connect it with a curved line. And that is what the graph would look like. Okay, let's try this one. So now we're going to be graphing a cubic graph, a cube root graph. So identify the domain. Then evaluate the function for several values of x and plot the resulting points. Connect the points with a smooth curve. So all the same steps are the same, except in this, the domain is all real numbers because the index number is odd. Therefore, we can plot many points, positive and negative, for this graph, okay? So if you're doing this, let's see. So I would say to plot perfect cubes, right? Okay, so let's say then let's go negative square root of 8, negative 1, 0, 1, and 8, because all of those are perfect cubes. So if I plug this in, I would get negative 2, negative 1, 0, 1, and 2. And then I can plot those on the next graph. And then they're plotting some that are not perfect cubes. I'm not going to worry about those because those are not fun to graph. So you'll see where those points are, okay? And now we just connect it with a curved line. And there you go. And that is a cube root graph. So now you've seen both a square root and a cube root graph. So you try this one. So identify the domain, evaluate the function for several values of x, and then plot the resulting points. So you have to identify the domain. Okay, so you should have gotten the graph that I have up here. That's what it should look like. The domain is x is greater than or equal to 0, and your range is y is greater than or equal to 2, because you start at where y equals 2 and you go up. Okay, so here's some extra practice I want you to have, so pause this and try to graph those. And then those were the answers that you should have gotten. So I know I've got this when I can find square roots, cube roots, and nth roots, approximate square roots, simplify radicals containing variables, and graph square roots and cube root functions. But do you really understand? So why is the cube root of negative 64 a real number, but the square root of negative 64 is not? The answer is because the first one equals negative 4, but there's no real number that when multiplied by itself gives a negative number. Explain how to simplify radicals such as the square root of 25x to the 6th. Assume that x represents a positive number. You would find a number that when squared or multiplied by itself gives 25x squared, x to the 6th. You will get 5x cubed.